Hello, welcome. This is teacher Shaba Frederick. And for this lesson, we are going to majorly focus on numerical methods with emphasis on error propagation, where we are going to see the errors in addition. So let us get started. So we are having that if the numbers capital X and capital Y are each approximated to small x and small y, with errors delta X and delta Y respectively, we want to derive an expression for the error in addition. So we are going to begin by letting our Z be equal to X plus Y. But remember, our capital X is equal to small x plus delta X, and then our Y is equal to Y plus delta Y. So meaning the Z is also equal to a small z plus a change in Z. So we shall say Z, which is Z plus delta change in Z or error in Z is equal to X plus the error in X. Then we add Y plus the error in Y. So here we are going to remove the brackets. So we have Z plus the error in Z is equal to X plus error in X plus Y plus error in Y. But remember, our small z is the same as small y, X plus small y. So Z plus delta Z is equal to X plus Y. So we can have them near to each other. Then plus delta X plus delta Y, which are the small errors in X and Y. So meaning this and that are going to go away. So we remain with error in Z is the same as error in X as the error in Y. So when we get here, we are going to apply the triangular inequality that error in Z is less or equal to error in X, the magnitude, plus the magnitude of error in Y. So we can conclude by saying that the error in Z is equal to error in X plus the error in Y. So the reason why we are giving them magnitudes is because at times some of these errors may be negative. So this is the expression for the error, for the absolute error in addition.